Okay, now I'm going to discuss binomial distribution, Bernoulli distribution, and Poisson distribution. Now, suppose a problem is like that: tossing a coin 4 times. What is the probability of getting 2 heads? Yeah, less than 2 heads or more than 2 heads, like that. So, tossing a coin 4 times and getting 2 heads, the possibilities are like that. Okay. Now, all are independent events. Now, probability of getting head 1 by 2, probability of getting head 1 by 2, probability of getting tail 1 minus 1 by 2, probability of getting tail 1 minus 1 by 2. Similarly, probability of getting tail 1 by 2, 1 minus 1 by 2, probability of getting head 1 by 1 by 2, probability of getting head 1 by 2, probability of getting head 1 by 2, and so on. Probability of getting hit 1 by 2, probability of getting tail 1 by 2, probability of getting hit 1 by 2, probability of getting tail 1 minus 1 by 2. So 1 by 2 square, 1 minus 1 by 2 square. Here it is also 1 by 2 square, 1 minus 1 by 2 square. And finally here also 1 by 2 square, 1 minus 1 by 2 square. Okay. Now, actually, all these are independent events. Head, tail, all are independent, and these are also independent event. So the possible outcome with this or this or this or this or this or this. Okay, so you have to add all this. So 6 into 1 by 2 square, 1 minus 1 by 2 square. Now we can do this one. Okay, now what happened if you write like this way: tossing a coin 400 times. What is the probability of getting 2 heads? Now, tossing a coin 4 times, we can use this particular concept. Now, what about if tossing a coin 400 times? So, is it possible to do like this way? Okay, possible, but it will take too much time, too much place, too much papers, pencil, time, everything. Okay, so there should be a formula. Here we have to apply formula for that. So the formula is, we have to apply binomial distribution. Its a formula is very simple. P x equal to x. Okay, that is nothing but fx. Fx means what? Probability mass function. Okay, ncx p to the power x 1 minus p to the power n minus x. So where n is the number of trials, say 4, n is equal to 4, x is our expected output, so 2 heads, so x is equal to 2. Okay, and what is p? P is the probability for success. If our interest is getting head, so it's success, so probability of getting head is 1 by 2. Similarly, probability of getting tail, it is 1 minus p. Okay, so it is 1 minus 2, it is 1 by 2. So what is the probability of getting 2 heads? So x is equal to 2. Okay, so that is f2. So 4c2 1 by 2 square 1 minus 1 by 2 n. What is n? N is equal to 4. 4 minus 2. So 4c2 4 factorial divided by 2 factorial, 4 minus 2 factorial. Okay, 1 by 2 square, 1 minus 1 by 2 square, that is 6 into 1 by 2 square, 1 minus 1 by 2 square. Okay, and now we can see both are same thing. Okay, so if to apply such type of concept, we have to use binomial distribution. Okay, now what is binomial distribution? Binomial distribution is a type of probability distribution for discrete random variable of a sample of n observations. The probability mass function of the event which follow the binomial distribution is follows. So this is nothing but our binomial distribution. Okay, uh, or probability mass function for the binomial distribution, where x is the number of events of interest. X is the number of events of interest, where x is equal to 1 to n, where x is equal to 1 to n. Okay, is the number of random experiments. P is the constant probability of an event of interest. 1 minus p is the probability of not having an event of interest. We denote the binomial distribution as follows. We denote binomial distribution like this way: x, capital X tilde b n comma p. Okay, where n number of trials and p probability of success are the parameters of the distribution. Okay, in a binomial distribution, number of success x is a random variable and the number of trials is a constant. A binomial random variable is a variable which follow the binomial distribution. Okay. Now, mean, variance and standard deviation. The mean, variance and standard deviation of the binomial random variables are, so the mean is NP. Okay. Uh, Variance is NP 1 minus P, and standard deviation is NP 1 minus P, square root of the variance, where n is the number of is the size of the sample space and P is the probability of the constant. Now remember something. Now each observation is classified into one of two mutually exclusive and collectively exhaustive. Okay, each observation is classified into two mutually exclusive. Now here head and tail, these two are the mutually exclusive events. Okay, if head will appear then tail will not, if tail will appear then head will not. Now collectively exhaustive. Okay, so only two options are there, head and tail. The result of any trial can be classified only under two categories. For example, yes, success or failure. So if head is the success, T is the failure. True, false, yes, no, defective, non-defective, like this one. Next, the probability of success P in each trial remains a constant for both with and without replacement. So probability of getting head here, 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 all the places, it should be the constant. It is same. Okay. The outcome of any observation is not dependent on any other observation, so that the probability of success in any trial remains unaffected by the results of other trials. Okay, so all are independent. The observation can be randomly selected either from an infinite population with or without replacement, or finite population with replacement. The sample consists of a finite number of observations, n. So here n is the finite number of observations. N is the finite number of observations. It is a discrete probability distribution and the distribution is specified by two parameters, n and p. So only two parameters are there, n and p. Binomial distribution may have either one or two modes. Now we can measure skewness and kurtosis of the distribution as follows. Now for skewness we use the formula 1 minus 2p by square root in p 1 minus p. Okay, and for kurtosis 1 minus 6 into p 1 minus p in p 1 minus p. Okay, now already know what is skewness, already know what is kurtosis. Kurtosis may be platykurtic, mesokurtic, leptokurtic. Skewness may be negatively skewed, positively skewed, okay, or normal. Now finally, if number of n is more, then the distribution is closer to the normal distribution. Okay, now solve some problems related to the binomial distribution. First problem: in a classroom, students has a 3% chances of feeling sleeping. Okay, in a classroom, 3% chance, 3% chance feeling sleepy. 3% means 0.03. Find the probability that out of 30 students, 3 students are feeling sleepy. Okay, so small is 30 and x is 3. So 3% students feeling sleepy. Find the probability that out of 30 students, 3 students are feeling sleepy. So we have to identify x is equal to 3. Okay, so formula is already you know, ncx. Okay, ncx p to the power x 1 minus p to the power n minus x. Now what is n? N is 30, cx. What is 6? Now what is p? P is 0 0.03, 0 0.03 to the power x, x is 3. 1 minus p, p is 0 0.03 to the power n minus x, n is what? 30 minus x. Okay. Now if you solve it, you can get the value 0.0481. Okay. So this is our first problem. Next, 3 coins are tossed. Find the probability of getting 2 heads. Probability of getting 2 heads. More than 1 head, at least 1 head will appear. Okay. So 3 coins. So next question. N is equal to 3. Okay. Now we have to identify getting 2 heads. Second, more than 1 head. So x should be more than 1 head. 2 heads, we can write 3c2 1 by 2, 1 minus 1 by 2 square. Okay, so it is answer is 0.375. More than 1. Okay, so more than 1 means we can write f2 plus f3. Okay, since it is f2, since it is f2, so if more than 1 means what? 2 and 3. So it's a very simple formula. So 3c 2 1 by 2 square, 1 minus 1 by 2 square, plus 3c3 1 by 2 to the power q. Okay, sorry, here it should be 3 minus 2. Okay, so here 3 minus 2, formula according to the formula 3 1 minus 1 by 3 minus 2. Okay, so addition of these two, is nothing but our 0.5. Okay, and finally less than 1. So less than 1 means at least 1 head. We can write, okay, at least 1 head means the value of x should be 1, 2 or 3. So here should be right like this. So it is, you can write like this way. So 1 minus f0, f0 means what? 3c0, 0.5 to the power 0. Okay, so 1 by 2 is 0.5 and another 0.5 to the power 3 minus 0, so 1 minus 0.125. Okay, so 0.875. Okay, next, the overall percentage of failure in a certain examination is 60%. Okay, so x p is equal to 0.60%, 0.60. What is the probability that out of 10 candidates at least 7 passed the exam? Okay, at least 7 passed the exam, so that means n is equal to 10. Okay, at least means what? Probability of x should be more than equal to 7. Okay, that means probability of 7, 8 9 and 10. Okay, so summation of, so the formula already you know, ncx, n is what, 10 c x p to the point 60 to the power x 1 minus 0.60 to the power n minus x, where x equal to 7 to 10. Okay, so it is 7 to 10. So if you solve it, we can get the answer, and the answer is 0.0547. The probability that you will win a certain game is 0.25. 0.25. If you play the game 25 times, what is the probability that you will win 13 times? That is 13 times, and at least 13 times. Okay, so 13 times, that we have to identify. Okay, so it's very simple. 25 C13, 0.25 to the power 13, 1 minus 25 to the power 25 minus 13. Okay, and the answer is 0.0025. Clear? Now second, at least 13. At least 13 means I is equal to 13 to 25, 25 Ci, 0.25 to the power I, 1 minus 0.25, 0.25, I minus, sorry, n minus I. Okay, so if you solve it, we can get the answer 0.0034 of this particular, okay, binomial part. Next we'll talk about Bernoulli. Okay, next, Bernoulli distribution. Now a random experiment whose outcomes is dichotomous. Dichotomous means it is true or false, success or failure, 0 or 1, with the probability p and 1 minus p, is called a Bernoulli trial. In such type of experiment, a random variable x is defined such that it takes the value 1 when true occurs and 0 if false occurs. Then the random variable x follows the binomial distribution. Clear? Now the probability mass function of binomial distribution is very simple. So fx is equal to p to the power x 1 minus p to the power 1 minus x. Okay, so it's a probability mass function of a binomial distribution. Next, Poisson distribution. Now assume n is equal to say 400 and p is equal to 0.001. Now if you want to apply binomial distribution, suppose x is equal to say 4. So the whatever is the probability of getting say 4, the output will be what? 400 C4, 0.001 to the power 4, 1 minus 0.001 to the power 400 minus 4. Okay, or if it is say 40. Now you can imagine that these are very small number, and power of smaller number say towards the more small number. So in this case we need something different. We need something different, probability mass function. So in this case we have to apply Poisson distribution. Okay. Now the Poisson distribution is a limiting case of the binomial distribution under the following conditions. Conditions क्या है? The number of trials n is very large. So if n is very large, probability of success p is the constant and very small p towards the 0, and the parameter of the distribution m is equal to np is finite. Okay, so the probabilities of success, so p is what? Probability of success is what? M by n. The probability of failure is 1 minus p. Probability of failure is 1 minus p. To represent the Poisson distribution we use m. Okay, so m is the Poisson parameter. Now the probability mass function of the random variable x which follows the Poisson distribution is okay, so e to the power minus m to the power x by x factorial. So what is e? E is a constant. What is m? M is equal to n into p. What is n? Number of trials. P is the probability. Okay, what is m? M is the np. What is x? Number of success. And finally x factorial. Okay, so where x is the number of occurrences of the random event, x is equal to 0 to infinite, e is the constant. So the value of e is what? 0.71, sorry, 2.7183. Okay, so 2.7183 is the value, and m greater than 0 is the parameter of the distribution, and it is the average number of occurrences of the random variable. Okay, now when to use Poisson distribution? Now setting up a new waiting lounge in a hotel to help decide on resource allocation, we need to know the various expected probabilities of the number of guests arriving at the hotel per hour. Practically, if we count the number of times a rare event occur during a fixed interval time, then the number would follow a Poisson distribution. Now remarks on Poisson distribution. Poisson distribution may be used as an approximation to the binomial distribution when p is small, n is large, and np is finite. Okay, so we can use binomial distribution, but if n is very large, p is very small, and np is finite, then in this case we may use Poisson distribution. The probability of x success in binomial distribution can be closely approximated by the probability of x success in Poisson distribution with the parameter m is equal to np. The Poisson distribution is used when p is less than 0.1 and np is not large, say less than 10. So in summary, Poisson distribution is a limiting case of the binomial distribution in case n is very large and not known or infinite. Second, the occurrence of the event is independent. Okay, obviously this should be independent. Events can happen at any point along a continuum. Okay, the Poisson distribution is a discrete probability, and theoretically an infinite number of occurrences of the event may be possible in the interval. The distribution is completely specified when m is known. Now the descriptive statistics of the distributions are as follows. So mean, so here mean is equal to m. Okay, variance is m, variance is equal to m. Standard deviation is standard deviation is of definitely square root of m. Skewness is 2 by square root of m, and kurtosis is 1 by m. That is the Poisson distribution is positively skewed and leptokurtic. Now the probability of a large single occurrence of the event in a given interval is proportional to the length of the interval. Poisson distribution may contain either one or two modes. In an exactly small portion of the interval, the probability of two or more occurrence of the event is negligible. Now solve one problem. In a radio making factory, the average number of defective radios is 5%. So P is equal to 0.05. What is the probability of getting exactly 4 defective? Exactly 4 defective in a sample of 100 radios chosen at random. So n is equal to 100. So probability of x is equal to 4. Okay, e to the power minus m. What is m? So what is m? M is equal to np, 100 into 0.05, that is 5. Okay, so e to the power minus 5, already you know the formula, e to the power minus m, e to the minus 5, m to the power x, 5 to the power 4 by 4 factorial. Okay, so the answer is 0.1755. Okay, so the probability of 5 defective in the sample is 0.1755. Next, 97% of the items made by a machine are not defective. Find the probability that 2 or more items are defective in a sample of 500 items. Okay, so in a second question, n is equal to 50. Okay, P is equal to 1 minus 0.97, that is 0.03. So what is NP? 50 into 0.03, it is 1.5. Okay, so probability of 2 or more defective. 2 or more defective means x is greater than equal to 2. That means 1 minus x less than 2. Okay, so 1 minus probability of x equal to 0 plus x is equal to 1. Okay, so 1 minus e to the power minus 1.5, 1.5 to the power 0 divided by 0 factorial plus e to the power minus 1.5, 1.5 to the power 1 and 1 factorial. Okay, and the answer is 0.4421. Okay, now next problem. A bowler has taken an average of 15 wickets in last 35 one-day international cricket match. Assuming that the number of wickets per match follows the Poisson distribution. Now find the probability that the bowler will take 5 wickets in a match. Second, the bowler will take less than 2 wickets in a match. And third, the bowler will take 10 wickets in a one-day series consist of 5 matches. Okay. So first of all, we have to identify the probability. So probability is what? 15 by 35. Why 15 by 35? So a bowler has taken average of 15 wickets in the last 35 one day international cricket. So that's why P is equal to 15 by 35. So and n is equal to say 1. So what is m? M is equal to np. So 1 into 15 by 35, that is 0.42. Now first question, the probability that the bowler will take 5 wickets in a match. Okay, so 5 wickets in a match means x is equal to 5. So e to the power minus 0.42, okay, 0.4 to the power 5 and 5 factorial. The answer is 0.000072. First question. Second question, the bowler will take less than 2 wickets. Less than 2 wickets means x is less than 2. That is probability of x equal to 0 plus probability of x equal to 1. Okay, so it's a very simple. E to the power minus 0.42 0.42 square by 0 factorial plus e to the power minus 0.42, 0.4 to the power 1 by 1 factorial. So the answer is 0.9330. And finally, the bowler will take 10 wickets in a one-day series consist of 5 matches. Okay. So now here n is equal to 5, not as 1. Okay, not a single match, it is 5 matches are there. So m is equal to np. So 5 into 0.42, sorry, 15 by 35. Okay, so the answer is 2.14. Now the bowler will take 10 wickets in a one-day series consist of 5 matches. So probability of x is equal to 10. Okay, so e to the power minus 2.14, 2.14 to the power 10 by 10 factorial. The answer is 0.00065. Okay, so the difference between Poisson and binomial distribution: if a mean or average probability of an event occurrence per unit time, per software module, per kilometer running, etc. is given, and you are asked to calculate a probability of n events happening in a given per unit time, per software module, per kilometer running, then Poisson distribution is used. If on the other hand, an exact probability of an event happening is given and you are asked to calculate the probability of this event happening k times out of n, then the binomial distribution must be used. So the application of Poisson distributions are as follows. Say number of trucks passing through a road crossing per unit time interval, number of cracks per unit area of metal surface, number of electronics items damaged in a given interval of time, number of wickets per match taken by the bowlers. Okay, so these are some possible examples. And finally we can solve one problem. Okay, finally, suppose the average number of tigers in Sundarban seen on a one-day safari is 7. What is the probability that tourists will see less than 2 tigers on the next one-day safari? Okay, so the mean value is, here mean value is given. Okay, so m is equal to 7. Okay, what is what that tourists will see less than 2 tigers on a next one-day safari? So less than 2 tigers means x less than equal to 1. Okay, so 7, 0, 0 factorial by 1 factorial. Okay, and answer is 0.0070. Okay, and that is the end of this particular video. Thank you.